Hi, everyone. This is your friend Bill Greeter, just taking you through a unit I call SMED Learning. Just the way I interpret SMED, and I kind of prescribe a way to implement it at PTA using your A3 process. So here goes. A couple things. One, I'm going to cover why people do lean. What is SMED? What are the benefits of SMED? What are the 8 components of SMED? And then how do I implement it into how we do our work? So lean obviously is a obvious sure way to make money. And it's really about increasing our productivity, right? Simply put, we can ship more with the same amount of labor, right? We can ship more and more because we're not doing as much non-value added work. We're doing more value added work, so our sales per labor hour goes up. One of my favorite metrics to use too is the concept of TIO, which is T is throughput, I is inventory, and operational expense is the O. Inventory is the money that you've invested in materials that your customers will eventually give you money for. Operational expense is the money that you've invested in labor and lights and equipment and machines and all that stuff. So their inventory and operational expense are both monies that you've invested. And throughput is the rate at which you can turn those two investments, your inventory and your operational expense, into cash. The faster I can do that, the more profitable I am. The slower the longer it takes me to turn that into cash, then obviously my profits are lower. The other thing about lean is we don't throw, it's just us not to throw labor at problems or spikes in demand or busyness, right? So lean's a sure way to make money. Now let's talk a little bit about the concept of SMED. And again, single minute exchange of dies, it means the changeover time is less than double-digit minutes, so less than 10 minutes. And there's full transmission lines, there's huge setups, at Toyota that are under 10 minutes, right? So it's a concept that is pretty much well established by Shigeo Shingo in the 50s, and it's to kind of combat bottlenecks, which are caused by long changeover times, which causes large lot sizes, which causes high water level on the floor, and the best companies turn SMED into a sport. So here's the problem. If you look at, there's 2 loops there. One is the risk and difficulty loop with regard to changeovers. And the idea is that we're going to run large lots. And the reason we run large lots is because then our large lots help us make setups infrequent. And because our setups are infrequent, then it means that we don't learn to do them all that well. And because we don't learn to do them well, then the setups are difficult and risky. There has to be rework sometimes, there has to be redoing it, the whole 9 yards. So that's one loop, is the risk and difficulty loop of why we run large lots. And then of course there's the cost loop. We run large lots because then we have seemingly reduced setup costs. And that makes us accountants happy. I'm not an accountant, but it makes accountants happy. And so we run large lots. The other issue is that we run large lots and it results in, again, a high water level on the floor, high inventory, which also complicates inventory control and ABC counts, and there's a whole bunch of stuff, expenses that are due to the fact that we have to have large lots and we have to have them sitting around. We can get them, they could be damaged. There's a lot of the 8 wastes that are involved in running large lots, motion, transport, defects, the whole 9 yards. So that's the problem we're trying to solve. And let's start with SMED in terms of understanding what setup time is. And it's pretty simple, right? Setup time is the elapsed time between the last part of the old run and the first good part of the new run. Simple as that, right? And the 2 distinctions I'd like to make right off the bat is, one, the internal setup are the things you have to do once the machine is stopped, right? And we want to try to limit those. And then the external setup are the things you can do before the machine is stopped. Those are all the things that we can do as soon as the machine stops. Those are things we can do before it stops. So the common sense is I want to do as much as possible while the machine's running. In other words, we want to do as much external setup as possible and then minimize the number of tasks that have to be done when the machine is stopped. And here's the 8 steps. The first thing we want to do, and a lot of times you can do this with video, pick a setup. Video is terrific. You can do it with your phone, set up a little tripod, whatever, but visually make a distinction between external and internal setups, and then change a lot of the things that are internal to external, right? And you'll be amazed just by observation how much of that you can do. And then continuously improve the internal and external, work on making those, a lot of that's done with 5S, not having to search or travel or motion to go get materials, and then standardize the functionality as much as can. These are all kind of progressive steps towards in SMED. Clamp versus threads, for example, just anything you can do to reduce the amount of time. Intermediate jigs, where you basically plug and play on certain types of equipment. Adapt parallel operations, where this is what we're talking about, people here, where the operator does part of the setup. It's not just left to the setup person. They kind of work as a team. And then eliminate adjustments. And then finally, mechanizing elements. So the game plan is 3 things to implement lean, no matter what we're trying to teach people. Is 1, education. Need to teach concepts so they understand the why and they can appreciate the why, the cause, the reason we're doing it. It's nice to add SMED projects to the A3 board, start with 1 setup and 1 leader, and just kind of go through those 8 steps. The metrics that I think that we look at when we're talking about SMED are 1, productivity. Some companies use productivity as miles per hour, how fast they're going. It's basically sales per labor hour, or TIO. 2, on-time delivery. And 3, the inventory level, raw and finished good in dollars, on a daily basis, where it becomes very visible, as you improve your ability to do changeovers, then I have less money sitting on the floor, or what Taichiono called sleeping money sitting on the floor, waiting to get damaged or transported or inspected or whatever. There's a quick video. Hopefully it'll run here. About 3 minutes long. So keep in mind, you notice that they didn't wait until the car got into the pit before they went and got the gas or went and got the tires, or all the external setups were done. Car pulls in, 12 seconds later, it takes off. I know it's an extreme example of a setup, but it's definitely a team effort. So a couple of some critical success factors for setup reduction. I think largely it's the operators and the setup people are the owners of the process, and we have to remember the respect for people part. It's their process; they own it. They do it every day. So it's important that they are part of the process and its results. It falls very nicely in the 5S and visual control programs. Again, I think we've talked about particularly Michael and Kent and I about lowering the water level. 5S and visual control is a good way to get down that road. It allows us to increase the flexibility in equipment, processes, and people. Helps us again with more, in developing our cross-functional teams. We want to focus on equipment uptime, teamwork, what becomes simple job changes, a whole bunch of stuff. These are all critical success factors, for SMED. And with that, that's the end of just quick learning unit. Looking forward to maybe getting project 2 on the board, working with Stanley and Lean Beret to lower the water level. And have a great day.